the United States has been testing new futuristic laser weapons on satellites. Firstly, what is a space weapon? Space weapons are weapons used in space combat. They include weapons that can strike space systems in orbit, like anti-satellite weapons, weapons that can attack targets on Earth from space, and weapons that can damage missiles traveling through space. During the Cold War, such weapons were primarily developed by contending superpowers, and several are still in development today. Military science fiction and sci-fi video games both feature several space weapons as a central theme. The Strategic Defense Initiative, SDI, popularly nicknamed as the Star Wars program, was a proposed missile defense system designed to protect the United States from ballistic strategic nuclear weapon attacks, intercontinental ballistic missiles, and submarine-launched ballistic missiles. President Ronald Reagan, a strong critic of the notion of mutually assured destruction, MAD, which he labeled as a death pact, revealed the concept on March 23, 1983. Reagan urged American scientists and engineers to create a mechanism that would eliminate the need for nuclear weapons. To manage development, the U.S. Department of Defense established the Strategic Defense Initiative Organization, SDIO, in 1984. A wide range of advanced weapon concepts were investigated, including lasers, particle beam weapons, and ground and space-based missile systems, as well as various sensor, command and control, and high-performance computer systems that would be required to control a system consisting of hundreds of combat centers and satellites spanning the globe and engaged in a brief battle. Through decades of extensive study and testing, the United States has a major advantage in the field of comprehensive advanced missile defense systems. Many of these concepts, technology, and insights have been transferred to future initiatives. The American Physical Society concluded in 1987 that the technologies under consideration were decades away from being ready for use, and that at least another decade of research would be required to determine whether such a system could be built. SDI's budget was repeatedly cut after the publication of the APS report. By the late 1980s, the focus had shifted to the brilliant Pebbles idea, which involved small orbiting missiles similar to conventional air-to-air missiles that were supposed to be far less expensive to produce and deploy. SDI was controversial in some quarters, with critics accusing it of threatening to destabilize the MAD approach, rendering the Soviet nuclear arsenal useless and reigniting an offensive arms race. The wider implications and effects of the program were examined through declassified documents from American intelligence agencies, revealing that SDI was a source of grave concern for the Soviet Union and her primary successor state, Russia, due to the potential neutralization of its arsenal and the resulting loss of a balancing power factor. Political support for SDI had dwindled by the early 1990s as the Cold War ended and nuclear arsenals were rapidly reduced. When the Clinton administration redirected efforts towards theater ballistic missiles and renamed the agency the Ballistic Missile Defense Organization, BMDO, SDI came to an end. With President Trump's signing the National Defense Authorization Act in 2019, space-based interceptor research resumed for the first time in 25 years. The program is currently managed by the Space Development Agency, SDA, as part of Michael D. Griffin's new National Defense Space Architecture, NSDA. L3 Harris and SpaceX were awarded early development contracts. Mike Pompeo, the director of the CIA, has since called for more funding to create a full-fledged strategic defense initiative of our time, the SDI-2. At least 3 laser systems are currently being developed for use in either space or on the ground. All 3 are a form of chemical lasers, in which chemicals are mixed inside the weapon to produce a laser beam. While a space-based laser is still 20 years away, 3 lasers are being considered for it: hydrogen fluoride, HF, deuterium fluoride, DF, and chemical oxygen iodine, COI, COIL. Lieutenant Colonel William H. Postle of the United States Air Force compared the workings of the hydrogen fluoride laser system to the workings of a rocket engine in a 1998 report titled Laser Weapons in Space, a Critical Assessment PDF file. Excited hydrogen fluoride molecules are formed when atomic fluorine reacts with a molecular hydrogen. The wavelength produced by this reaction is between 2.7 and 2.9 microns. The Earth's atmosphere would absorb the hydrogen fluoride laser beam at that wavelength, making it most likely to be used in space-to-space combat as part of a space-based laser program. In a simulated space environment, the Ballistic Missile Defense Organization has already demonstrated a megawatt hydrogen fluoride laser. The deuterium fluoride laser system is another laser that works similarly to the hydrogen fluoride system. Deuterium is used to react with atomic fluoride instead of molecular hydrogen. Because deuterium atoms have more mass than hydrogen atoms, this laser has a longer wavelength of about 3.5 microns, allowing it to pass through the atmosphere more easily. TRW demonstrated the Mid-Infrared Advanced Chemical Laser, MIR-ACL, a deuterium fluoride laser capable of producing more than 1 megawatt of power in 1980. In 1996, this type of laser was used in tests at the White Sands Missile Range to shoot down a rocket. The chemical oxygen iodine laser, COIL, which first appeared in 1978, is the third type of chemical laser that could be used in ballistic missile defense. A reaction between chlorine and hydrogen peroxide in this laser system excites oxygen atoms, which then transfer their energy to iodine atoms. The iodine atoms are excited as a result of the energy transfer, resulting in a laser with a wavelength of roughly 1.3 microns, which is smaller than either of the two lasers previously mentioned. Because of the shorter wavelength, smaller optics could be employed to create a space-based lasing system. TRW tested a COIL laser in 1996 that produced a multi-second beam with hundreds of kilowatts of power. This is the most promising of the space-based lasers under development right now. One of the issues with space-based lasers is that they would have to be attached to a moving satellite while attempting to hit another moving object traveling at thousands of kilometers per hour. Imagine shooting a bird from a cockpit of a supersonic jet. Because the laser and the item it is attempting to strike will most likely be traveling at opposite speeds, the shot will be nearly impossible. This is why the U.S. Department of Defense is exploring developing a particle beam weapon capable of firing subatomic particle beams at near light speeds at a military target. If a beam could be launched at those speeds, it would effectively freeze the thing being targeted. A particle beam weapon might generate power many times greater than any laser now in development. A power source and an accelerating tunnel would be the main components of such a weapon. If a working particle beam weapon could be created, it would use its power source to accelerate electrons, protons, or hydrogen atoms through a tunnel, focusing these charged particles into a beam that could be launched at a target. Many international treaties now restrict the development of such weapons into space, which is understandable. What used to seem like science fiction is now becoming reality. The era of space lasers is arrived. Hopefully, these lasers will never be used and will only be seen by aliens as proof of human intelligence. However, they appear vital because hundreds of billions of dollars are floating above us in orbit in the form of satellites, and they are fully vulnerable to attacks. This must change, and it happens that the US, Russia, and China are already leading the way in ensuing this. Tell us what you think about space weaponization in the comments section. Also, check out our video on US Navy testing fastest ship to move tanks, weapons, and troops.